Sophos XG Firewall with version 18 has introduced a new threat intelligence feature that leverages deep learning techniques powered by Sophos AI as well as Sophos Labs, along with Sandstorm scanning to protect against advanced and zero-day threats for email and web traffic. In this video, we will discuss and demonstrate how administrators can configure and further understand the detailed information available in the new threat intelligence reports. As a prerequisite, make sure that the XG device is running on version 18 firmware and there is an active subscription to the Sandstorm module. First, we navigate to Protect Rules and Policies Firewall Rules and click on the Add Firewall Rule button. Enter an appropriate name, select the rule position and group, action as Accept, the logging option enabled, and then select the source zone as LAN. In the Source Network section, we configure an IP host object having the IP address of the computer that will download the malicious file. Select the destination zone as WAN and keep the destination network and services as any. Optionally, the administrator can also enable authentication and select the required users or groups as the matching criteria. In this example, we have selected the user John. In the Security Features section, make sure to enable the Scan HTTP and Decrypted HTTPS option, and then enable the Detect Zero-Day Threats with Sandstorm option, and finally, save the firewall rule. We have already created a SNAT rule in the NAT Rules section to source NAT the outbound traffic with the default masquerade policy. Now navigate to Advanced Threat Sandstorm Settings, and here you can select the closest data center locations based on your region, as the suspicious files will be uploaded to the selected data center for further analysis. Additionally, you can also exclude various file types from the Sandstorm analysis process. In this example, we will try to download a malicious file from a website, and, as we can see, the download activity has failed. Now to investigate further. On the dashboard page itself, we can see the Threat Intelligence widget, and once we click on it, it redirects us to the Threat Intelligence tab, showing the list of file downloads that were blocked and subjected to Sandstorm scanning. Clicking on the plus icon will show the details such as username, IP address, the source domain, and the action taken on that file. We can also filter the list based on the file types and even the status associated with the file analysis. Hovering the cursor over the status of the file will show the overall verdict of the file analysis, along with the components that were used to determine the final result. Once we click on the View Report button, it will open a new tab and display the detailed report of the file analysis investigation, and how the final action was derived for that particular file. On the right-hand side, it shows various modules that are responsible for the file analysis process, and the administrator can click on any of those modules to skip to a particular section. As you can see, machine learning, reputation, and file analysis components use the static analysis approach to determine the behavior of the files. Sandstorm detonation components use the dynamic analysis approach, as it allows the files to execute and accordingly determine its behavior. Investigation and actions, overall verdict, and analysis summary use a combination of both static and dynamic analysis. Now here are some of the key differences of the static versus dynamic analysis approach. In static analysis, there is no need for the file to be executed, whereas the dynamic analysis allows the files to be detonated in a sandboxing environment. The static analysis uses machine learning models to understand the structure and features of the file, whereas the dynamic analysis focuses on the behavior when the file is detonated in order to determine the verdict of the file. The overall processing time for static analysis is much faster as compared to dynamic analysis. In dynamic analysis, as the file detonates in the sandbox environment, snapshots are taken throughout its execution process and further displayed in the Reports section. Now, coming back to the reports. The Investigation and Actions section shows the name of the file along with the source details such as username, IP address, source domain, time and date, and the action taken on the file. The Overall Verdict section shows the nature of the file based on the combined outcome of static and dynamic analysis. The Analysis Summary section displays the true nature of the file as detected by various layers of analysis, both static and dynamic. It also shows various attributes of the file, such as the file type, SHA-1, SHA-256 hash values, the file size, and more detailed information can be found by clicking on the All Details option, which is useful for threat hunting. Now, one of the key benefits of using machine learning is that it can identify the file quickly with high accuracy, and it also compares the file with millions of known good, benign, and malware samples. The machine learning section goes into detail of each different type of analysis, such as feature analysis, feature combinations, and structure analysis. Each component gives its own result of whether the file is malicious or not. Even though each of these components might not be a strong indicator on its own, but in combination they provide critical insight for the analysis. The Feature Analysis section breaks the file down into specific features and shows for each individual feature if it is more prevalent in good or bad files. If it displays more percentage for red color, then it is more likely for the feature analysis to determine the file as malicious. The number of files used for analysis should be interpreted as percentages. Out of 10 million files, the actual number of files used in the test for the feature analysis is confidential and can vary. In this report, we can see that the Stack Canary option is disabled. It is known for protecting against stack buffer overflow attacks in applications. The Feature Combinations section highlights a combination of features that provide a strong good or malicious signal. It starts with one feature of the sample file and checks how many good and bad files have that one feature in common. Next, it combines another feature and again checks for files having similar features. At each stage, it counts the number of good or bad files having all those features in common and sees if the combination is more prevalent in good or bad files, and keeps on repeating this process until there's a more precise indication of the file type. The Structural Analysis identifies the nature of the file using 32 distinctive structural genes, and matches it with the file to check the likelihood of gene presence matching with known good and bad files. Once the gene matches the file being analyzed, it will show the red-colored bars for a malicious file or green-colored bars for a clean file. The more red bars shown in the result, the more likely the file is determined to be malicious. The next section is Reputation, which is a part of the static analysis process, and it does the live lookup of Sophos Labs data to determine when and where the sample file has been seen earlier. The results can include malicious, suspicious, clean, or unknown verdicts. The Sandstorm detonation shows the overall verdict of the file after allowing it to be detonated in a sandboxing environment, along with the fine analysis details such as submission and detonation date and time, duration of the analysis process, the file type that was executed, as well as the SHA hash values. The Malicious Activities section shows the complete list of the malicious activities observed during the detonation of the sample file. The list is classified into various sections, such as network, memory, suspicious, etc. Malicious detection shows the list of detections from Sophos products that are used during the detonation process of the sample file. This includes detections from Sophos Antivirus and Intercept X as well. It also includes the lookup information for URLs that are accessed during the detonation process. Then it captures the real snapshots of the file behavior inside the sandboxing environment during its detonation process. This allows the user to see the behavior of the sample file and anticipate the repercussion if the file was allowed to be executed in the real environment, resulting in the cyber attack. In the process section, it shows the list of processes that are created by detonating the sample file. It gives information about each process along with the command line that triggered the process. This is helpful for the analyst to understand more about the behavior of the sample file. The Network Activity section shows information about network access during the detonation of the sample file. It also gives information about the DNS lookups, connections, and traffic flow detected during the detonation process of the sample file. Similarly, the Registry Activity section shows information about the registry changes done during the detonation of the file. It gives information about the process and the key values that are manipulated for registry keys. Here is the report of another sample file having more information about the File Analysis section. The File Analysis section uses the static analysis process and shows detailed information about the sample file. In general, these sections provide technical information about the files that are most useful to the malware researchers. Often, they would see items in these sections that are clear indicators that the file is malicious. Signature and certificates will show the status of the sample file, whether it has been signed or not, and if it is signed, then it shows the signature date and time as well. The File sections indicate certain packers, compilers, and functionalities that are interesting to the malware researchers. Then the Resources section gives more indication about the tools, languages, and frameworks used to produce an executable. And finally, the Imports section indicates where certain libraries used in malicious ways are being imported. For example, password stealers. For the known sample files, it will also show VirusTotal reports, having a link that redirects to the VirusTotal website showing which other products currently detected the same sample file as malicious. The link to the VirusTotal page for that particular sample file is displayed to the customers only for reference purposes, and its data is not used to take any verdict on the sample file. In summary, static analysis is the fastest type of analysis, as it uses machine learning and other technologies to consider the structure and features of the file, while the dynamic analysis reviews the actual behavior of the file as it is executed, looking for malicious behaviors and other suspicious activity. Through the combination of both static and dynamic analysis, the threat intelligence in version 18 blocks malicious content quickly and accurately. We hope you liked this video and thank you for watching.